Our next theorem is going to show that the operation of multiplication modulo m is well defined. Namely, if we have two elements that are congruent modulo m, so again, this tells us that the equivalence class of A is the same as the equivalence class of C. We have another two elements that are equivalent modulo m, so the congruence class of B and D are the same. Then the conclusion of our theorem is that the congruence class of AB is the same as that of CD. So this says that no matter how we choose to represent this congruence class or equivalence class modulo m, the operation of multiplication gives us the same answer. Okay? So it's a well-defined operation to just multiply then reduce modulo m. And let's prove this. So how does it start? Well, we're going to suppose that A is congruent modulo m to C, and B is congruent modulo m to D. All right, so that's just starting with the hypothesis, and then we say what we're going to do. We show that AB is congruent modulo m to CD, or equivalently, m divides AB minus CD. So that's what we want to show. Since A is congruent to C modulo m, and B is congruent to D modulo m, we know that m divides A minus C and m divides B minus D. Now, AB minus CD, that expression that we want to show that m divides, we can do some clever adding and subtracting here, I believe. I think if we add in a BC and subtract off the BC, then some magic's going to happen. So there's a B in both of these terms. Multiplication in the integers is distributive, so we can and it's commutative, so we can factor out that B. And then similarly here, we can factor out that C. Scroll down a touch. Now, what do we know? Well, since m divides A minus C, we get and B minus D. Well, it's certainly going to divide any number times them. So m divides B times A minus C, and C times B minus D. We'll divide both of them. So what do we have here? Well, we have an integer is equal to a sum of two integers, and m divides both of the terms on the right, so it must divide the term on the left by the 2 out of 3 property. And this is what we wanted to show. Let me just write one more sentence to be clear about what we proved. So we conclude from this that AB is congruent to CD modulo M.